Product rule was the first on your graphic organizer. Product rule means if you have like bases, you keep the base and you add the exponents. When I look at this problem, all I see is k's, so I'm going to keep the k, keep that base, and I'm going to add together the exponents. 3 plus 2. And then you have to simplify, which gives me k to the 5th. On number 2, we have a p squared times p. The second p has an exponent of 1. If there is not an exponent, you give it a 1. P squared times p. Keep the p, add the 2 plus 1 to get p to the 3rd. The reason we add is if we expanded this, you would have p squared as p times p, and then when you multiplied by another p, you would have had p times p times p, which is p to the 3rd. It's shorter than having to write it out longhand every time. Yes? Number 3, 2n to the 3rd times n. 2 is a coefficient. It is also a base. We're going to keep it. It does not combine with anything, so it will just stay 2. Now I have n to the 3rd times n. I keep the base, which is n. I will add the exponents, 3 plus, this one doesn't have an exponent, so it is a 1, giving us 2 times n to the 3 plus 1, which becomes 2n to the 4th. On number 4, we have a 2 and we have a 3. Both are coefficients. They are also bases, but they can be simplified. 2 times 3 makes 6. Once we multiply, we don't need them anymore. That leaves me with x to the 1 and x squared. I keep the x, add those exponents, and when I simplify, I get 6x to the 3rd. Number 5, n squared times n squared. The only basis there is n, so we keep the n. They have exponents of 2, so 2 plus 2 makes n to the 4th. Keep the base, add the exponents. On number 6, x times x is just x squared. Right, the power rule. The power rule says that if you have a base with extra exponents, or a base with 2 exponents, then you are going to keep the base and multiply those exponents. Number 10 is the only true power rule here, and it's r cubed to the 3rd. You keep the r, and then you have 3 times 3 gives you r to the 9th. Keep the base, multiply the exponents. You're going to see a parenthesis on these every time. And you're going to notice that there's an extra exponent. It's going to look funny. Now 7, 8, and 9, we're going to use the power rule, but we also have to use the product power rule as well, so we're just going to talk through that. Now when you come to this one, what you should notice is that you have 2 bases. You have the 3. It's a coefficient of 3, but it can also be a base. So 3 times a cubed. That's your problem. I just spread it out. Now, my exponent 3 has to be distributed to each of the bases. So I'm going to have 3 to the 3rd times a to the 3rd to the 3rd. Now, 3 cubed you can simplify. It is not 3 times 3. It is 3 times 3 times 3, which is 27. Now, on the a cubed cubed, or a to the third, you should also notice that it reads funny. This is your power rule. A to the third, keep the a, multiply those exponents. 3 times 3 is 9. On number 8, 3p cubed squared. The 3 and the p cubed are going to get squared. Separate it out. 3 times p cubed squared. We're going to take this 2, take the exponent, we're going to distribute it to both of the bases. So we're going to have 3 squared times p to the third squared. 3 squared is 3 times 3, which makes 9. P to the third squared becomes p to the 3 times 2, which makes 6. This is your final answer. Last one here is number 9. We've got 2x cubed. We have to cube the 2 and we have to cube the x. Take this exponent and distribute it to both of those bases. 2 times x cubed is going to be 2 cubed. And then we will also cube the x. Now that 2 cubed needs to be simplified. It is not 2 times 3. It is 2 times 2 times 2, which is 8. That is your final answer. These are the product power rule. We was already doing some of those. We've got 3a squared squared. What we've got to do is identify our bases, 3 and a squared, and then we are going to square both of those. Take this 2, distribute it, so 3 squared times a squared squared. 3 squared is 3 times 3, which is 9. A squared squared becomes a squared times 2, which is a to the 4th. And that is your answer. Number 14, I've got 2x cubed squared. So separate the bases, 2 times x cubed, and then we want to square it. This exponent of 2 has to distribute 2 squared times x cubed squared. 2 squared makes 4, and x to the third squared becomes x to the 3 times 2, which is x to the 6th. And that is your final answer. Number 15. 3x squared. You have a 3 and an x, both of which want to be squared. So we're going to distribute. We'll square the 3. We'll square the x. 3, nope, that's a square, sorry. 3 squared is 9, and x squared stays as x squared. 2x squared cubed, separate those bases, 2 times x squared cubed. We have to distribute the cube. So we have 2 cubed and x squared cubed. 2 cubed is 2 times 2 times 2, which is 8. And x squared cubed is x to the 2 times 3, which is x to the 6th. (17) is very simple. This one is just the power rule. 3 cubed squared, n cubed squared. Keep the n, multiply the 3 times 2 to get 6. On number 18, the 2 and the x squared need to be cubed, so we're going to distribute. 2 cubed times x squared cubed. 2 cubed is 2 times 2 times 2, which is 8. And x squared cubed is x to the 2 times 3, which is x to the 6th. Okay, 19. We've got 2m n to the 4th times m to the 3rd n to the 4th. There are two different ways you can approach this problem. You can start by combining like terms here and then distributing the 4, or you can start by distributing the 4 and then combining like terms. My advice would be to simplify it as much as possible before distributing the 4. So when I work through here, I'm just going to try to group everything together and combine it. I see this 2. It has no like terms, so it is going to stay 2. Now, once you have accounted for it in the next step of your problem, it's okay to mark that out. I am going to keep it in parentheses, though. Now, I've got m to the exponent of 1, n to the 4th, m to the 3rd, n to the 4th. So if I want to use my base m, I have a 1 and a 3, and I combine those by addition. So m to the 1 plus 3 gets rid of both of these m's. Now I've got n to the 4th and n to the 4th. So I'm going to put n, keep the base, and I'm going to add those exponents, 4 plus 4. That's everything that was inside the parentheses, and I haven't touched this exponent out here yet, so I have to keep it on the outside. Now I'm going to simplify one more time before I distribute. 2 times m to the 4th times n to the 8th. All I did was combine my addition. Now I have 2m to the 4th n to the 8th to the 4th. Now I'm ready to distribute my exponent 4. 2 is going to get 1, 2 to the 4th. M to the 4th is going to get 1. And n to the 8th is also going to get 1. I've distributed it to each of the bases. So 2 to the 4th, that's 2 times 2 times 2 times 2, which makes 16. M to the 4th becomes m to the 4 times 4, which is 16. And n to the 8th to the 4th becomes n to the 8 times 4 is 32. And that is your final answer. Right, we've got 2u squared times 2u to the 4th v squared to the 4th. Again, I'm going to start inside the parentheses. 2 times 2 gives me 4, so I can get rid of those 2's. Now I've got u squared and u to the 4th, so I keep the u and I'll add together the 2 and the 4. The last base is v squared, and I still have that 4 on the outside of the group. I need to combine my 2 plus 4, so 4 times u to the 6th times v squared, and each one of those is going to get that to the 4th exponent. So I'm going to distribute 4 to the 4th times u to the 6th to the 4th times v squared also to the 4th. Everything got a copy of that exponent. Now I just need to simplify. 4 to the 4th is 4 times 4 times 4 times 4, which is 256, I believe. 4 times 4 times 4 times 4. 256. U to the 6th to the 4th, we multiply, gives us u to the 24, and v to the 2 times 4 gives us v to the 8th. And that is all. It is in simplest form.